Hello everybody, my name is Andy. Welcome to my Coding Dojo. Today we're going to be doing the Fizzbuzz Kata. So this is a pretty basic kata. Let us get started. I'm using the form that comes from the Coding Dojo Handbook, and that says, write a program that prints the numbers from 1 to 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fizzbuzz. So, the goal of this is not to solve this problem, but to practice how we solve problems and how can we improve that. So let's go ahead and jump into it. Let's go ahead and open up our Fizzbuzz code. So right now this is essentially just placeholder. And let's open up our tests because we're going to TDD this. Go ahead and get that on a side by side. And since we have tests, we want to make sure they're running. So we'll open up our command line and npm test will start up jest. So right now it's listening for changes. And if we see here, if we change this to 1, it'll say we have a failing test. So this was just an example. We want to go ahead and comment that out. So from this function, I think we should be returning an array that has all of our results in it. That'll make it easy to do whatever we need to do with it. So let's go ahead and write a test for that. Let's go call it returns array. Create a little anonymous function here, and we expect that when we call fizzbuzz, is array. Is that what we want? So isArray failed. So isArray is not a function. Let's go to the jest documentation. I have that open here. This is just learning jest, so we're going to jump in and see matchers here. Common matchers. To be null, to be true, to be undefined, to be truthy, to be falsy. Numbers, strings, arrays, and iterables. To contain. Okay. Array containing, to have been called, to have returned, to have length. That might be what we want. Let's see if there's one that's more exact. To have length. Okay. So it doesn't look like they have the exact function that we need. Let's try array dot is array, and we'll do it like this instead. Okay. Why did that pass? let's go look up array is array. So we have array functions, is array. Oh, I think we just wanted to say to be truthy. There we go. So we expected is array to be true, but it is false. So here, to make this true, I think we only need to return an array. There we go. So the next thing we wanted to print the numbers from 1 to 100, except when it's 3. So let's go ahead and write a test to make sure that there's numbers in there. So let's call this let's say it returns numbers, we'll say by default. Maybe we'll need a better name for this as we go along, but it's better for us to get moving and see how things shake out. So we expect that when we call Fizzbuzz and we look at the first item, we expect that to be 1. So here, remember where our arrays are 0 indexed. Let's go ahead and make this pass. Let's go ahead and go turn this into a variable. So we have we'll call them values. It's a new array. We're going to go ahead and return that array. And we are going to, let's go ahead and push 1 on there. Expected 1. No. Okay. What is our problem? Expected 1, received undefined. Okay. Our function here isn't actually right. We want to put the array of the... So if you didn't follow that, here we want to call the function and then get the index of what comes back. So that was a typo. Okay. So here, let's go ahead and add another expectation. We expect the next one to be 2. Okay. We expected 2, and we've got undefined. So here we could go ahead and push another number on there. And we could do this all day, but at this point in time, let's go ahead and set ourselves up a loop. So I is less than or equal to 100. And let's go ahead and we will increment I each time. And each time we will push I. Okay. Oh, so we wanted to start with 1. So we want to go from 1 to 100, not from 0 to 100. There we go. So now we have an array. Let's go ahead and put a couple more in here just to spot check. We're not going to do 3, but we will do let's do 4, and we'll do another number that's quite a bit higher. So the 4th number. Sorry, I was talking and typing at the same time and typed what I spoke as opposed to what I needed. To be 4. And let's do something much bigger. So the the biggest one we could get to, so if we go to number, so 99 would be divisible by 3, 98. Let's go something like 27. And that would be the 26th item. Okay. So it seems like our numbers are working well. Let's go ahead and test that for 3. We want to put in fizz instead of 3. So say returns fizz instead of multiples of 3. And so we expect that our third item will be fizz. Okay, and instead we get the number 3. So let's go ahead and say if I equals 3, values push fizz, and then else we go ahead and push our numbers in there. So if we hadn't done this, then we would have pushed 3, and then all of our numbers behind it, 4 and 27, those would all fail. So we would have failed other tests. Okay. So our test says return fizz instead of multiples of 3. We're only testing for 3. We're not really testing for multiples of 3. So let's go ahead and set some others up here. So let's look at 9. Okay, so that didn't work. So instead of here being equal to 3, we want it to be if it's evenly divisible by 3. Oh, looks like my math was wrong. 27. Yeah, okay. So let's go make this 28. So there is some embarrassing math that you see. We're gonna go and keep it in there. Show you this is about getting to the solution and not about the solution itself. So now let's go ahead and add a couple more tests here. Let's go big. So we want our 99th number, instead of being 99, to be fizz. Okay, so that seems like that's working pretty well. Let's go on to our next criteria. So instead of the number for multiples of 5, print buzz. So let's go ahead and create a test for that. Returns buzz for multiples of 5. So fourth item to be buzz. Okay, instead we got the number 5. So we can go over to our code and we can kind of already see a pattern coming out here. Let's go ahead and if I is a multiple of 5, evenly divisible by 5, we can okay, so we didn't break anything. And our tests all pass. So let's go ahead and expand this out as well. So let's go ahead and create a couple more. So let's do 10, and let's do 100. Okay. So all those are working well. Let's see. So we create our array, we loop through, we add fizz or we add buzz, and then we return that. Okay, so that seems pretty straightforward. Let's go ahead and look at our last requirement. For numbers which are multiples of both 3 and 5, print Fizzbuzz. For multiples of 3 and 5. Okay, so I believe our first one that is a multiple of both 3 and 5 would be 15. Okay, so actually we had a typo here. Sorry, 14. There we go. So we wanted Fizzbuzz instead of fizz. So you see our first catch caught that it was multiple of 3, and then our second one did not fire, which is good. So I think what we'll go ahead and do is we'll just add another rule here and turn this into an else. So if so we could say I is a multiple of 3. So we could either do I as a multiple of 3, or we could do I as a multiple of 15, because all of our numbers that are 3 and 5 would also be a multiple of 15. That's if you trust the math of somebody who messed up 27 earlier. But I'm going to go ahead and be a little bit more specific. Our kata said for numbers which are both multiples of 3 and 5. So I'm going to go ahead and write it out like that. I think it's better to closely match the code to the problem. Now, this problem is a fake problem, but if we were in a real environment, we would want to use names that match the domain that we're working in, and we'd want to use the same words that non-technical people use, because that's going to be cause a lot less confusion in the future. If somebody else comes along and they do modulus of 15 instead of 3, that's not wrong. It's just not the way that I do it. We're going to go ahead and push Fizzbuzz. Okay. And so if we go and check 30 or 60, that would work as well. So our problem says we want to print the numbers from 1 to 100, but for multiples of 3, print fizz instead, and for numbers for For multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fizzbuzz. So we have a function that's doing that. Let's just go ahead and console out that solution and see what we have. Nope, console log. Okay. And if we go over here and we say node fizzbuzz.js, there we're printing out an array. Let's go ahead and fizzbuzz, and we'll do a values dot maybe for each. If we go back and rerun that again, there you see we have 1, 2 fizz, 4 buzz, fizz, 7, 8 fizz, buzz. So unless we've made some mistakes, I think this meets our requirements. But let's, so writing it is one thing, but more important is for us to look back at what we've written and see how we've done, how we could do things better. Let's go ahead and I'm going to go ahead and move this to the right so we can have it on screen at the same time. So the book Coding Dojo Handbook has both the kata and some of these tips for how you can look back and see what you've done. So so here's the discussion points that the author suggested. So, is the code you have written clean? Okay, well, it's kind of a big, I mean, it's not a huge function, but it's a thing. You're going to have to read through it to understand. It's not terrible. Are there smells? Well, let's continue on and so if you see any smells that you think are bad, go ahead and comment in the comments, and maybe there's things we can improve next time. I plan on doing these multiple times so we can see how things progress. Did you refactor throughout or do it all at the end? So we didn't do much refactoring here. We didn't do any refactoring on our tests, and our tests are there's multiple expectations in each one. I'm not too against that per se. Now each line is a little confusing, especially since we have to know the index of our array. That is an easy way to cause confusion. So maybe there's something we could have done better there. That's something to think through. What if you had a new what if a new requirement came along that multiples of 7 were whiz? So we could obviously do that just by adding another else if. But could you add that without editing the existing code? And no, we couldn't. We would have to jump right back in here. Cue discussion of the open-closed principle. So, um, yeah, that's this. What we've written here is um, easy to edit, um, but if we're adding more functionality, we're going to have to come back in and edit it some more. So next time, I think that's a good thing to work towards next time is how can we do this without modifying things each time and start working for that, working towards that. Um, because with an example like Fizzbuzz, this is such a simple problem that if you really are making a program about Fizzbuzz, this is perfectly fine. Um, but when you get into more complicated things in the real world, um, this open close principle is a real thing. You really do want to start think about, okay, how can we add to this without having to modify what we've already written? How can we add more rules to that? And so, um, I think that that wording, adding rules, is going to be our hint for next time. Um, what are our rules, and how do we add more of them? Um, So ideas for after the dojo. When you got it all working for fizz and buzz, add whiz for multiples of 7. So we're going to talk about that next time. Then add fizz for all numbers containing a 3 instead of 23 and, for example, 23 and 53. So right now our code is all about modulus. Um, so these are things to work on next time. So really the point of this was to get us a good baseline so we can start talking about these bigger concepts as we go forward. So um, join me for next time where we'll do the exact same um, uh, task, but we will try to be thinking more about how we can extend what we've written. So join me for that. I hope you enjoyed this. I enjoyed doing it. Thanks a lot.